All right, so section 11.2 is on series and summation notation. Okay, so we learned about sequences last time. So sequences were things like 1, 3, 5, 7, 9, and so on. A series is going to be when you add up all of the terms in the sequence. Okay, so it's the sum of a sequence. Summation notation or sigma notation is a convenient way of notating the sum of terms in a sequence. So you'll see this a lot with the little sigma sign. So I call it sigma notation. Your book usually calls it summation notation. All right. So basically what this means, k equals 1 is where you start. So you start plugging in 1 and you stop with n. So if I have a sub k, I'm going to plug in 1 for k, then I'm going to plug in 2 for k, 3 for k, 4 for k, and then all the way to n. So I'm going to have A1, A2, A3, A4, all the way to AN. And then the sigma sign means sum, so you add them all together. Okay, so you start with 1 and you stop at n. So in this first example, I have k equals 1, where I'm starting, and I go to 6. So I'm going to plug in 1, 2, 3, 4, 5, and 6. So I'm going to have 2 times 1, plus 2 times 2, plus 2 times 3, plus 2 times 4, plus 2 times 5, plus 2 times 6. So you end up with 2 plus 4 plus 6 plus 8 plus 10 plus 12. And if you add them all together, you should get 42, I believe. 42. Okay, on the next one. On the next one, I start with 0, start, and end with 4. Okay, so I'm going to have 2 over 0 factorial plus 2 over 1 factorial plus 2 over 2 factorial plus 2 over 3 factorial, and I stop by plugging in 4. Okay, notice this is different than the first 4 terms, because see how we had 4 things here? I didn't stop there just because I had a 4 on top. 4 meant I plug in every single number until I get to 4, and then that's where I stop. Okay, do you guys remember factorials? So factorials, if I had 3 factorial, 3 times 2 times 1. So what's 0 factorial? Do you guys remember?
1.
1. What's 1 factorial then?
1.
Also 1, right? So 0 factorial and 1 factorial are the same number. All right, 2 factorial is 2 times 1, so it's 2. 3 factorial is 6, and 4 factorial is 24, right? 4 times 3 times 2 times 1. You already had 3 times 2 times 1, now multiply by 4 to get the next one. Okay, so this means I have 2 plus 2 plus 1 plus 1/3 plus 1/12. Okay, let's get our calculators out and let's use our fraction button on our calculator. So we don't use that very often, so let's try it. So I'm going to have 2 plus 2 plus 1 plus, you can put 1/3 in parentheses, but your calculator will actually kind of do that for you. It does order of operations already, so you don't actually need parentheses. So you can say plus 1 divided by 3 plus 1 divided by 12. Okay, when I do that, I get this number. Okay, but I know it should be a fraction. Minion, can you close that door, please? Thank you. So I know it should be a fraction because I just added a bunch of fractions together to get it. So how do I get it?
Second math.
Yeah, you hit math, and then it's the first choice. So it has a little triangle fraction. So it says change to fraction. Hit enter, enter. You get 65 over 12. Leave your answer like that. I hit math, and then it was the first choice. So enter. Okay. Now, what I was telling you that I didn't stop after writing it 4 times, right? I wrote 1 more because I went from 0 to 4 is very important because on your homework I always have one like this, like 30 to 39, which is kind of annoying because you have to start with 30. So 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So if you go from 0 to 39, you have 10 numbers that you're adding together. But what people do every single year, it drives me crazy, is they'll plug in 30 and then they'll plug in 31, and then they keep going until they have 39 numbers. not 10 numbers, 39 numbers, which is crazy on their homework, so don't do that, okay? So you're only plugging in 30 to 39. All right, so number 2, so write each series in summation notation. So if you're writing in summation notation, these are the ones I always hated when I was in school. Because when I look at this pattern, I'm like, oh, 3, 6, 9, 12, 15. I'm thinking, oh, I'm adding 3 each time. Is that what you guys were thinking?
No.
No? What were you thinking?
3 times the number of terms.
Yeah, so this is actually multiples of 3. Okay, but what I did when I was in school, so you can write this or you can leave it off, is I would say, oh, is it k plus 3? Because each time I'm adding 3. And then I was like, okay, well, that means I'd have to start with k equals 0 in order to get 3 for my first term. But then when you plug in 1, what do you get? Yeah, you get 4. That's not 3, 6, right? So we did something wrong. So the key is to know that you somehow are using the multiple of 3 thing. So if you think about it, this is 3 times 1, that's 3. The next one's 3 times 2, 3 times 3, all the way to 3 times 5, right? Guess I could have written 3 times 4 in there. Okay. So when I set it up, I'm going to start, I'm going to put 3k in there. So that means I start at 1, and I go all the way to 5. And that's your summation notation.
How come you don't have to write like k equals 5?
We just don't. Yeah, you could write k equals 5 on top, but we just don't. We always just write it on the bottom. All right, so this next one. So what are some different patterns you see? So Casey, what do you see? Yep.
So,
What's the first thing you notice? LJ, help her out. Anything that you notice about this problem?
it's minus plus.
It goes minus, plus, minus, plus. Okay, so it switches signs each time. In other words, it's what we call alternating. Okay, what else do you notice? Denominator gets bigger. What's happening with the denominators?
It's a square.
They're squares, right? This is 2 squared. This one's 3 squared. This one's 4 squared, 5 squared, 6 squared. So I'm feeling pretty confident that our denominator is going to be k squared. Now the numerator looks like it would be 2, except it's alternating. It's switching signs. So we need to somehow take that into account. So whenever something is alternating, that means that you will need either -1 to the k or -1 to the k plus 1. One of those will work. We don't know which one. So let's say I put in -1 to the k. And I'm starting at k equals 2, because it's 2 squared, right? And I'm going to k equals 6. So 6. So plug in 2. If you plug in 2, you have -1 squared, which is 1, times 2, so you get 2, over 2 squared, which is 4. Is 2/4 the number that I want?
No.
No, I want -2/4. So what we do is we, instead of writing k, we say k plus 1. Basically, we need to multiply by another -1. So now when I plug in 2, I get -1 to the third. Well, what's -1 to the third? -1. So I have 2 times -1, which is -2 over 4. And that's what I want. And you can check the other ones and they will work. Okay, so this is the series that we want. So it's tricky. Another thing to mention is don't be surprised if we use things other than k. A lot of times you'll see series with j's, i's, n's. These are all pretty common subscripts, so don't be surprised if you don't have k.
What if the like variable is different than what they give you on the sequence?
Yeah, like later on in math you'll see things like 3k, j, I, and then we'll say I equals 1 and j equals 2, and then they might kind of combine it. So they might have multiple things. So they'd say, I think you'd have to, well, I don't know. You might just have like one number there, and then they might have a double. Crazy stuff. All right. So fourth partial sum. So it says for the series, find the fourth partial sum. Notice how it goes from I equals 1 to infinity. So at first you're thinking, wait, if I'm going to add an infinite number of numbers, I'm going to get infinity. But not necessarily. So you'll see why in this case. All right, fourth partial sum means add up the first 4 terms. So first 4 numbers. Okay, so if I plug in 1, I get 6 over 10 to the first. If I plug in 2, I get 10 to the second. Plug in 3, I have 10 to the third on the bottom, and 10 to the fourth. This would be the fourth partial sum. Okay, the first one is 6 tenths. 6 tenths, when you guys first learned decimals, what decimal is that? 0.6, right? That's 6 tenths. The next one is, right, 10 squared is 100. So we have 6 hundredths. So that's 0.06. The next one is 6 thousandths. 0.006 and 0.0006. That means the fourth partial sum is 0.6666 for them. So if I want to find from I equals 1 to infinity of 6 over 10 to the I, it's going to be 6 tenths plus 6 hundredths plus 6 thousandths plus, and so on. What are we going to end up getting?
0.6
Yeah. Do you guys understand that? Do you guys see how when you added these, you had 0.6666, right? Because it'd be 0.6 plus 0.06 plus 0.006. You line up the decimals, and so on. All right, so this would be 0.6 repeating. Yeah, Brian's ahead of the game. He's saying that's 2/3. Do you guys agree? 2/3, because 0.3 repeating is 1/3, so that's 2/3. Actually, if you guys, do you know this trick with the repeating things? So if I had 0.11111, that's 1/9. 0.22222, that's 2/9. 0.33333, that's 3/9, but what's 3/9? 1/3, right? And so on. So if I had 0.88888, that is 8/9. Crazy.
1.9.
Good question. So 0.9 can be proven to be 1. Because 0.11111 is 1/9. So if you multiply by 9 on both sides, 0.99999 is 9 over 9, which is 1. Am I confusing you? Tricky, tricky. Okay, so Carl Friedrich Gauss. Gauss rhymes with mouse. It's not Gauss. So Gauss was a famous mathematician. And when he was a kid, he was a prodigy. So he's very smart. But when he was a kid, he was also very ornery. Do you guys know what I mean by ornery? Did your grandma use that word? I use that word. All right, so it's probably the Indiana pronunciation. All right, so he's very, got in trouble a lot. Was just a very annoying little kid. So there's 2 different stories. So the first story says that Carl was very ornery, and he got in trouble one day in class. And the teacher put him in the corner, probably in a dunce cap, remember those days? All right, and told him that he could not leave the corner until he added up all the numbers from 1 to 100. Now keep in mind, at this time, he is 10 years old. Think about you when you were 10 years old. Would you be able to add up all the numbers from 1 to 100? So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. That would take a while, right? All right, he did it very quickly, just a couple minutes, and he came back to her and he said, I know the answer, it's this. And she said, there's no way that you found the answer. That can't be it. Go back to your corner. He's like, no, here's how I found the answer, and showed her, much to her surprise. Okay, so that's the first story. The second story is, although we do know that he was kind of an annoying kid, I guess, the whole class was in trouble, though. So the second story is that she just wanted like 30 minutes of peace and quiet, so she was like, okay, the whole class until you guys can add up all the numbers from 1 to 100, we are not going to move on. And she just wanted to sit at her desk and relax. And he came up to her, showed her the answer. She didn't believe him. Turns out he really had it. So those of you that were here on Monday, you kind of know the trick, so don't spoil it. Anybody, so any sophomore that was not here, if you're on the college trip, do you guys know the trick? It's what?
It's 8 or 950.
8 or 9 what?
800. It's 850 or 950.
Nope. It's bigger. 5,050? Is that Santiago that's saying that?
No,
It
it's
is
me.
5,050. Who said it? What does it mean? All right, it's 5,050. Here's what he did. So there's how many numbers in this list? 100 numbers, right? 1, 2, all the way to 100. All right. So he paired up the first and the last. Paired up those. He saw that the first and last added up to be 101, and the second and second to last made 101. 101, right? 101. So if you have 100 numbers, that means you have 50 pairs of 101. So then, being the smart kid he is, he didn't just write this out as 101 times 50 and then find it that way. He was like, oh, I can do this in my head. 101 is 100 plus 1, distributive property, right? So 50 times 100 is 5,000. 50 times 1 is 50. So your answer is 5,050. 50. Yeah, smart 10-year-old, huh? All right, Carl went on to do a lot of things in math. He does a lot of things with chapter 11, so a lot of the sequences and series things. When was he alive? I can't remember the exact dates, but a while ago. Over 100 years. All right, so number 5. So use mental math to estimate each sum. So if you have 11 plus 12 plus so-and-so until 30. All right, so we need to think about how many numbers we have. I know that if I add the first and last, I get 41. Okay, this is very much like SAT questions. Like SAT questions are always like, if you read from page 49 to page 71, how many pages have you read? And so a lot of you guys are like, oh, 79 minus 40, or 71 minus 49. Okay, I'd get 2 there, carry the 1, 2, so you'd be like 22 pages. All right, that's not actually how that works. Because if I read from page 1 and all the way through page 10, how many pages did I read? No, 10. So you can do 10 minus 1. You get 9. You need to add 1 to it. So basically what's happening is you're not counting that first page when you subtract. So you need to add 1. It would actually be 23 pages. Okay, so if I have the numbers 11, 12, and so on, how many numbers are in that list? Right, there's 20 numbers in the list. Here's an easy way to think of it. I always think of tacking on the numbers 1 through 10. Now I would have the numbers 1 through 30. 1 through 30, I know there's 30 numbers there. 1, 2, 3, there's 30 numbers, right? All right, but I'm subtracting out 10, the first 10. So that means there's 20 numbers. So that's kind of an easier way to think of it. Okay, so we have 20 numbers, so how many pairs? 10 pairs of 41, so that would be 410. All right, this one's even harder. Okay, I gave you a hint. You don't have an even number of pairs this time. So one way that some people think about it is they think about, well, what if I had 2, 4, 6, and all of those numbers in there? What if I had all the even numbers? How many numbers would be in the list then? 101, right? So I'm going to take out the even numbers. How many do I have now? Do I have 50 or do I have 51? 51 numbers. Okay, here's an easy way to think of what you have. 1 and 101 make 102, right? These also make 102. What's the number in the very middle that doesn't have a pair? 51, because in order to make 102, it needs itself, right? 51 plus 51 makes 101. So it's the only one that doesn't have a pair. So the number in the middle is 51. So we basically have, let's see, we had 25 pairs with the number 51 in middle. Okay, so we had 102 times 51. Or wait, 25. Messing it up. And then plus 51. So you could do this in your head. You'd say 25 times 100 plus 2 plus 51. So you get 2,500 plus 50 plus 51. So if I add 101 to 2,500, you get 2,601. Okay, there's also another easy way to do this one. If you notice that you have 51 numbers, take off the last one. Then pair them up. Do they still make the same number each time? Yeah, this time they make 100. So we'd have 2,500 plus the last number, 101. That way it would be a little bit easier. So sometimes you can think of the number in the middle. Sometimes think about just taking off the one on the end. It doesn't matter. All right, so do you feel pretty good about 11.2? Okay.